everyone, and thank you for joining us in our talk about scaling ski resort forecasts using Snowflake ML. It is very on brand for Snowflake and this conference to get to do this project. So I'm Marie Coolset. I'm on the solution innovation team at Snowflake. What we do is we do projects with customers, build out using new features, and we got to do that with Alterra for this project. You can see some of the results of this project here in a Streamlit app. So this is one of the resorts that we forecasted visitors for in the last ski season. And I'll hand it over to Eli to talk a bit more about Alterra and what they're doing with machine learning.
Thanks, Marie. Hey, I'm Eli. I'm a data scientist at Alterra Mountain Company. And Alterra is a large ski company. Does anybody here ski or snowboard? Hey, wow, nice, okay, sweet. Yeah, we own 18 resorts, I think it is now in North America. We own a couple heli-skiing companies, some ski-related software companies. Most notably, we run the Icon Pass, which grants access to dozens of premier ski destinations around the world. And at every one of our own resorts, we've got a bunch of ancillary businesses. It's like lodging properties, rental, F&B, retail, ski school. So there's a lot going on in our business, which means there is a lot of ML opportunity. We have a lot of opportunity to customer segmentation, predicting who's going to purchase what, trail usage analytics, media mix modeling. But we've got a small data science team for a really large company. So we had to prioritize, and our top priority was predicting demand at our ski resorts. Super important to know how many visitors we're going to have on a given day at a ski resort so that we can staff appropriately, make sure we have enough parking, enough food, enough lift operators. And it just improves the guest experience when we know how many people are coming. Currently, we do predict visits, but it's a really manual process. We've got a bunch of revenue managers at every resort sitting in a room with a spreadsheet, looking at what happened last year, what happened last week, and just kind of trying to figure it out. It's a time-consuming process, high opportunity cost. They're pretty high-value employees making predictions relatively inefficiently. The process isn't currently standardized across our ski resorts, and of course, they don't consider all the variables that a model can. So for this project, we wanted to automate and scale this prediction of how many visitors we'll have at every resort. But there were quite a few challenges involved in this. First is that skier visitation is really variable due to weather. If you have a great snow day, you're going to have more visitation. It's also a really seasonal business with high periodicity within the week and just seasonally, like in the winter. And for about a third of the year, ski resorts are closed, so traditional time series modeling does not work well for our business. And the third challenge is that this manual process that we use actually predicts pretty well. So we were up against an entrenched system that predicts well, and we wanted to get somewhat close to that, ideally beat it. So we approached this problem by building one model for all of our owned resorts. You can see all the owned resorts on the left-hand side of the screen there. And for every resort, we wanted to know who's visiting on an Icon Pass, who's visiting on local passes, paid tickets, frequency products, and overall for every day, for every resort, for the entire season. And so we built two large buckets of models. One of them was a long-term season forecast that we run once at the beginning of the season, predicts for the whole season. And then the second group of models are these short-term models that we run every day for the next 10 days. And the short-term models incorporate a lot more data, like weather, more recent lag variables, econometric data. I think we have like fuel price as a variable in there. So pretty cool. So both of these models are predicting every single day of the season at different intervals in advance. So I'll hand it over to Marie to talk about the Snowflake side.
Okay, so I'm going to go over the technical solution. This is the architecture diagram for it. Starting with the data there, we had lots of different data sources. So we had our weather data, of course, our holidays, the Alterra visit data as well. Once we have that in Snowflake, we did our feature engineering using Snowpark. So getting our previous year features and transforming some of our date features. Because we were using Snowpark data frames, it was then really easy to just turn that into a feature view within a feature store. Now, using a feature store is awesome because it captures all those transformations so you can access them at training, but also access them at inference. And it automatically updates and refreshes. So as new features come in, as new weather forecast data is available, then you have that available in the table automatically. Once we have our training data, we trained XGBoost models in parallel using a user-defined table function. We partitioned on resort and product. So we had many models that we then registered in the Snowflake model registry. So for this presentation, we're going to kind of dive in to feature store and Snowflake model registry, which we used in sort of unique ways here, and kind of go over that. So feature store. I love using feature store. I will not do an ML model without it. I don't think you can do a lot of very complicated things and advanced things with feature store, but you can also just use it in a really simple way. So how I use it here is think of it basically as a table where each row has every date in the past and a bunch of dates into the future for every resort with every feature you want to use in the model. And you have that table, it's represented, and you can easily join it in to exactly the subset that you want to use. You don't have to specify any join logic because the join logic is captured as part of the feature view. And so again, it has a super clean, easy to use Python API that I'm going to show you. And an example of how we used it to handle sort of a complicated situation is with our short-term forecast. So the types of features that we use for this, for our season forecast, we use previous year weather, previous year visits, dates and holidays. And then for our short term, we also added the weather forecast and the recent visit trends. And for the example we're going to show today, this, especially around the recent visit trends, this becomes a bit complicated in order to organize your features so you're not leaking data to the model that shouldn't be available to it. So for the short-term forecast, we use lead forecasting, which means we have a separate model for each day out that we're predicting. So if today is January 4th, we're in the thick of the ski season. We predict 1 day out to January 5th. That's one model. We're going to predict 2 days out to January 6th. That's another model. And each of those days that we're predicting is represented in our feature view. So we have the weather forecast for that day. We have what day of the week it is, if it's Christmas, if it's a holiday. So that's captured in our feature view. But that's more complicated for our recent features, like what was the visits yesterday? Because if I'm jumping ahead 6 days, that data doesn't exist yet. So it makes it a bit more complicated of how you want to represent that in your feature view. So what we did is we created a completely separate feature view to handle the recent features. And those are around the day that the forecast is being made. So that will be January 4th. We're going to call that the forecast date. And that has its own feature view with all of the lag features up to that date. And then we have another feature view with all the features around the target date, which is the day that's being predicted. So I'm going to go in, show a quick demo of how that looks and how easy it is to grab those features. All right. So we are in the Snowsite environment. Here we are under the AI/ML tab in the feature interface. We can see all the feature views we created. We have them at the product level and the resort level. We're going to focus on the resort level because it's a little bit simpler. So we have our forecast date feature view, which is around the day we're making the forecast. We can see we have several versions, many iterations, many mistakes made as we develop this. And we can see all of the features within here. So we have weather data up to that date. We have all of our lag past 7 days, and we have some rolling averages. And then if we go into the target view, that's where we have our holiday information, the previous year information, and the weather forecast for that day as well. Now, the join logic that I talked about is captured for a feature view in the resort target date entity, so in the entities. If we click into this, we can see the entities for each of these feature views, which is basically the join keys that we use. So for the resort target date, we have the target date and destination name. For the forecast date, it's the forecast date destination name. It's the exact same at the product level, except we also have the product group as an entity key as well. So now I'm going to go into a Snowflake notebook to show you how easy it is to kind of actually access these features and how you would use it for inference or for training. So here we are in our notebook. We import our libraries, and then we need to initialize our feature store. And then once we do that, we have to create our base table. So that's going to be what we join into. So we have our base table here. And what we can see is we have the forecast date. For every date, it's January 4th. And we have that for each destination name and each lead, or each day out that we're going to predict. So the next thing we have to do is add the target date to this as well. So we add the target date by just adding the lead to the forecast date to get our target date. So January 4th, lead of 1, we're predicting January 5th. Lead of 2, January 6th. Lead of 3, January 7th. So now we have our forecast date, destination name, and target date, and we can access the features from our feature views. So to do that, again, this is all it is. It's very clean. We just use the retrieve feature values. We specify that base data frame and specify the feature views we want to join in and the versions that we're using. And then we can see we have our table with all of our features here. So we have our forecast date, destination name, target date, and then we have our forecast date features, so the weather up to that point, and then we also have our target day features, so the day of year, day of month, day of week. All right, and now the next thing I want to quickly highlight and talk about, well, first to say, so as we can see, this is the most important features for one of our resorts for the 1 day out forecast. And I highlighted the lag features there. So they are really important in determining the forecast and how many visitors are coming. So it was important for us to find a sustainable way to be able to bring those in and support them in our pipelines. Now, the next thing I want to talk about is model management and how we use model registry here. So as we talked about, we predicted at the resort level and at the product level for the season and the short term. But then we did make it a bit more complicated because we also wanted to predict at different partition levels, just for science to see which was better. So we predicted an individual model for each resort product, but then we also trained a combined model as well. So if you can see in that chart with the 3 different plots there, the red one is the lowest partitioned model. So each of those dots has a model for it. And the lighter blue is the least partitioned model. So that one is a single model across all resorts and product groups. That's looking at the MAPE, so lower is better. You can see it's a little bit tighter. I wouldn't say there was any huge improvement in one method or the other, but it was fun to try. But all that to say is we had a lot of models, so we had over 1,000 models in our model registry, which technically was fine. The model registry handled it fine, but from kind of an organization perspective, it was fairly overwhelming and a lot to manage. So it was great when partway through this project, they released the partition model API. And what this is it allows you to define a function where it will grab the specific model for a partition, and you can register that to the registry, and then you can run inference with a single line of code by specifying the model partition ID, which really simplified the model management process. And I'll quickly, again, just show what that looked like and how we went from over 1,000 models, and Eli was a little bit worried about having to maintain this project, to really simplifying it. So here we are again under AI and ML in the models interface. And now we just have 10 models, and it's great. And you can click into one of those models, and you can see all of the versions that were done for this. Again, a lot of iteration throughout this project. If we go to the most recent version, one thing that's great is in the metadata, we actually would capture which feature store version was used, so you could always connect the correct feature view with the model. You can see exactly the code in Python and SQL to run inference and all of the features involved with it. So that was a huge success in just kind of simplifying the management of models. But with that, I'll hand it over to Eli to talk about the results and the impact.
Yeah, so for us, the million-dollar question was, how did these turn out? Were the models any good? And on the left-hand side, you can see a couple line charts. This is for one of our resorts, Winter Park in Colorado. And on the top, there's overall visits for all of last year. And on the bottom, it's paid ticket visits for all of last year. In red are the actual visits. In black is the revenue management forecast, our manual method of doing things. And then in blue, we have two of our models, the 3-day out and the 7-day out model. And you can see just from looking at the line chart, things are looking pretty good. We follow the peaks and valleys pretty well of actuals and track closely with revenue management. So this was kind of like this was not our best performing resort. It was an average one. So we considered this for sure a win. On the right-hand side, you can see bar charts that look at percentage difference from actual for the different prediction methods. So lower is better. In black is our manual method. And then in dark blue is our 7-day model forecast, which was an 18% improvement over revenue management, the previous way of doing it. And then once we go to the 3-day model in light blue, that's a 20% improvement over revenue management. So this was like exactly what we wanted to see, either matching or beating our current prediction methods. And the closer we get to our target date, the better the models are performing. So awesome. So where do we go from here? I think with these models, we're going to test them this year and use them kind of as a tool in the tool belt of our revenue management team, see how they work, see if the team likes using the models, revise and update over the summer. And then for the 26-27 ski season, we'd love to be not doing any sort of manual predictions and just transition to these models. So, lessons learned.
So, lessons learned from building this out. The key takeaways is, number one, use Snowflake notebooks on container runtime for ML. I hope you've heard that a lot this week, but this project was mostly built on warehouse notebooks because they weren't available in Azure at the time. And then right at the end, they became available, and we just quickly switched them over, and it was a huge cost savings right away. So that was a great learning. And then also using Snowflake Feature Store, it is so easy to use. It's a few lines of codes. It continually updates your data. It makes it easy to access between your inference and training pipeline. So explore that. The documentation is great and straightforward. So that's a good one. And then Snowflake Model Registry as well. So wherever possible, I try to create clean handoffs between version objects. So going from Feature Store and passing that straight to the model and having the model be a registered pipeline with other transformations. So then you get those version handoffs. And then also, as you saw, using the partition model API for managing partition models is a huge win.
And from our end, I mean, our learnings were really, you've probably seen this in a bunch of presentations, but Snowflake made this so easy. We already have our data warehouse in Snowflake. It's where our compute is. Having our ML capability there, it's super easy. It's using SQL and Python, which are languages we already use. And the resources that Snowflake provided made this so much easier. Marie and team kind of bringing this to completion, and all the tutorials and resources available were great. Moving forward, we're going to tackle a huge backlog of modeling projects now that we've done it on Snowflake. As I mentioned, customer segmentation, forecasting purchase behavior, media mix modeling, lots of opportunity. And we are out of time.
All right, out of time. Good timing. And our call to action, though, this QR code has a link to a quick start that follows a lot of the same methodology we used. In fact, it was being developed at the same time we were working on this project. So some of our model evaluation code is directly in this project. So try it out yourself.
Thanks.